Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Good evening, students. Welcome to Brilliant Katha. Again, another session of MCQ discussion for your CBSE board examination. Today's discussion will be on two major topics, my dears. You can see on the board, the topics are three-dimensional geometry and LPP. Very easy topics. We are expecting assertion, reason question from three-dimensional geometry this year. Okay, so we should be ready for that. So the concept from MCQ is enough for assertion, reason as well. Okay, so here linear programming and 3D geometry total take-ups around 4 MCQ questions from your board examination. So we'll be discussing the major concepts and topics for MCQ discussion. So we'll begin with three-dimensional geometry, my dear students. Three-dimensional geometry majorly asks questions for MCQs from direction ratios, direction cosines, then the condition for perpendicular lines, and major concepts of point of intersection of two lines, angle between two lines. So major MCQs all comes from this. Let's start our discussion. Question number 1. If the direction cosines of a line are 1 by a, 1 by a, 1 by a, then what do you know about the value of a? We know the most famous relation that exists between the direction cosines of a line. What is it? The most famous expression. We use this in vector algebra also. When I discussed the MCQs of vector algebra, I said this very clearly that day. L squared plus m squared plus n squared. The direction cosines of a line. Right? So L squared plus m squared plus n squared equal to 1. So all of them are 1 by a. So I can say 1 by a squared plus 1 by a squared plus 1 by a squared equals 1. Okay, so it's 3 by a squared equals 1. So a squared equals 3. So a is equal to? Yes, answers already has come. Very good, my dears. Very good, Shiny, Hanna and Karthik. It is plus or minus root 3, option D. My dears, a question based on this property is almost sure in your board examination. L squared plus m squared plus n squared equals 1. Question number 2. Again, this time they are talking about the direction 90, 135 and 45. So it's going to be cos 90, cos 135 and cos 45. Cos 90 everybody knows it's 0. Cos 45 everybody knows it's 1 by root 2. Cos 135, many students know it, but for those students who are not familiar with obtuse angles just subtract from 180, you get 45. So the corresponding acute angle is 45. So cos 45 is 1 by root 2, but in second quadrant cos is negative, so minus 1 by root 2. Very easy technique to find the value of an obtuse angle. Just subtract from 180, get the corresponding acute angle, get the value for that acute angle and put the correct sign in the second quadrant, because obtuse angles are in the second quadrant. Okay, right answers already have come on the screen. Yes, G, Hanna, Dia, Shiny, Ruben, Satvik and Hridya. Very good. Option A, 0, minus 1 by root 2 and 1 by root 2 are the direction cosines of this line. So learn direction cosines in both ways. Direction cosines of a line can be calculated by knowing the angle the line makes with the three axes alpha, beta and gamma. Cos alpha, cos beta, cos gamma. And the second way is divide the direction ratios of the line with the corresponding magnitude. Yes, direction ratio divided by the magnitude also gives us the direction cosines of a line. Question: if a line makes angle alpha, beta and gamma with the coordinate axis respectively, then what's cos 2 alpha, cos 2 beta, cos 2 gamma? Trigonometric formula, my dears, of 11th standard. What's cos 2 alpha, cos 2 beta, cos 2 gamma? 2 cos squared alpha minus 1, 2 cos squared beta minus 1, 2 cos squared gamma minus 1. Trigonometric formula of 11th standard. Now 2 comes out common with cos squared alpha, cos squared beta, cos squared gamma, minus 1, minus 1, minus 1, minus 3. So we already know what is cos squared alpha. Cos squared alpha is the direction cosine number 1. Cos squared beta direction cosine number 2. So L squared plus M squared plus N squared, which whatever be the line is always 1. We have learned that. I already stated that property before today. Yes, L squared plus M squared plus N squared is always 1. So using that same logic, what's L squared plus M squared plus N squared here? Again 1. So answer 2 minus 3. Answer is minus 1. And that's option B. Yes, right answer. Very good. G, Hanna, Dia. Yes, Smriti, Shiny, Karthik. Very good, my dear. So all of you are very familiar with these concepts. Give a lot of importance to direction cosines of a line. An angle made by a line with the axis and the corresponding direction cosines obtained from the angle. You will get a question in the board exam based on this. A very high chance is there. Okay. Now the angle between the two lines. Do you see that this looks like the equation of a line but not in standard form? Yes, when you try to write the standard form, the coefficient of x should be made 1. So x divided by half minus 0. Y divided by 1 by 3 minus 0. Z divided by minus 1 minus 0. This is the standard equation in Cartesian form for the line. Now the second one, x divided by 1 by 6 minus 0, y divided by minus 1 minus 0, z divided by minus 1 by 4 minus 0. Now they're asking you to find the angle between the two lines. Remember, my dears, it's an MCQ. The normal formula for angle between two lines is cos theta is equal to A dot B divided by magnitude A magnitude B, where A and B represents the direction ratios of the lines. In Cartesian form, it's actually A1 A2 plus B1 B2 plus C1 C2 divided by magnitude of A, which is A1 squared, B1 squared, C1 squared, magnitude of B, which is A2 squared, B2 squared and C2 squared, because it's too long for an MCQ. So the anticipation that you should have in your mind is, for these kind of questions, normally I am anticipating the angle to be 90, and 90 only happens if A1 A2 plus B1 B2 plus C1 C2 becomes 0. So I am anticipating it as 90. So what I am trying to do is, I will do this first. Anyway, if it is not 0, I can apply it in the formula and get the actual angle. So I am anticipating, so I am only doing this. So A1 A2 plus B1 B2 plus C1, C2. Remember, my dear students, why I am only doing A1, A2, B1, B2, C1, C2? Because it is MCQ. So my anticipation may be that this angle is going to be 90 because 90 is one of the options. So it's 1 by 12 minus 1 by 3 plus 1 by 4. You take LCM, it's 12. So 1 minus 4 plus 3. Answer is definitely 0. Therefore, theta is 90 degrees. This condition becomes 0 only if the lines are perpendicular to each other. It's an anticipation, my dears. It's not that it's always going to work out. Okay, if it doesn't become 0, put that here and then you do what? The normal one. But that is not going to be 1 mark. So, option D, 90 degrees. Very good. Answers came from G, Hanna and Ruben. So please remember, I didn't do the whole formula. This is like a 5-mark question, some part of a 5-mark question, this angle between two lines. So if they ask for MCQ, and my dears, this was previous year board question. So they can ask this. So when they ask a question based on this, normally the anticipation should be it is 90 degrees. Moving on to the next one, my dears. Equation of a line passing through origin and making 30 degrees, 60 degrees and 90 degrees. Definitely angles given to us. So what is L? Cos 30, which is root 3 by 2. What is M? Cos 60, which is 1 by 2. And what is N? Cos 90, which is equal to 0. According to the Cartesian form of a line, the equation is x minus x1 by A, y minus y1 by B, z minus z1 by C is equal to some arbitrary constant, say lambda. But this direction ratios are actually obtained by multiplying the direction cosines with the magnitude. Okay, so I can say this magnitude M L y minus y1 magnitude, so I say magnitude, I use some other variable, say k. Okay, so how do you obtain the direction ratios? Direction cosines is ratio by magnitude. So direction ratio is direction cosine into magnitude. And do you see that? Do you see that the k is common for everybody? And according to the idea we have studied, this k will be assigned along with the arbitrary constant. So I can simply write it like this also. So I'm trying to tell you that there is nothing wrong if I write the equation of a line with the direction cosines. There is nothing wrong if I write the equation of the line in the denominator with the direction cosines. So what will be my new equation here? With the point line passing through origin. So the point x1, y1, z1 is 0, 0, 0. So what's my equation? X minus 0 by root 3 by 2, y minus 0 by 1 by 2, z minus 0 by 0. So x by root 3 by 2, which is going to be 2x by root 3. Y by 1 by 2 is 2y and z by 0. So look at the equations here. Look at the equations here. Which equation matches my answer? Option B. Option B. 2x by root 3, 2y by 1, z by 0. Option B is your answer. Please all of you cross check. Please all of you cross check this idea. See, you have learned writing the equation of a line with the denominator as direction ratios, and I am telling you now there is nothing wrong if you write the same Cartesian form with the direction cosines in the denominator. Got it? Because the arbitrary constant is so powerful that it can take up any common constant from this equation to itself and still remain an arbitrary constant. Clear, my dears? Because always the denominator is expressed in the simplest form. So we can write it in the form we get it. Got it? Okay. The equation of y-axis, for these kind of questions, I always tell my students to remember a very, very simple thing. The question says y-axis. When the question says y-axis, your answer is what is not mentioned in the question. Very simple idea. The question says y-axis, your answer is what is not mentioned. What is not mentioned? X-axis and z-axis. So your answer is option A, x equal to 0, z equal to 0. So please keep the small trick in mind. When the question only talks about one axis or two axis, whatever is not stated in the question, that will be the answer in the option. That answer option will have some speciality. So here, look at all the other options. It talks about y, but only option A doesn't talk about y. So question talks about y, the answer must be x and z. So what's the answer? Option A. So for y-axis, definitely for a point in y-axis, we know that x must be 0 and y must be a value and z must be 0. 0, y, 0. 0, y, 0. So x equal to 0, z equal to 0. Option A. All of you understood, my dears? So, sir, if the magnitude is mentioned in the question, do we still consider the DCs as the denominator? I can. See, if the normal question talks about direction ratios, but if the question makes us to find the direction cosines, you don't need to simplify it to the direction ratios because it automatically covers. It automatically covers. Are you all clear now? Yes. Now, the vector equation of z-axis, my dears. I want the vector equation of z-axis. Okay. So all of you, I'm going to write the equation of the line now. Listen very carefully. Listen very, very, very carefully. The idea is, if you want to write the equation of a line, you need a point on the line and you need the direction ratios of the line. I am going to teach you to memorize the direction ratios of the axis. All of you, I am trying to teach you the direction ratios of all the axes. For x-axis, the direction ratio is 1, 0, 0. For y-axis, the direction ratio is 0, 1, 0. For z-axis, the direction ratio is 0, 0, 1. Keep in mind. Very simple. 1, 0, 0, 0, 1, 0, 0, 0, 1. Same direction cosines also. Because the direction cosines are obtained by dividing with magnitude. What's the magnitude of 1, 0, 0? It's 1 only. So you divide with 1, it doesn't change. So direction ratios of the axis, the direction cosines of the axis, both of them are the same. In the previous question, they are not asking you the equation of the line in the normal Cartesian form or vector form. Now they are asking the equation in the normal form. So if you talk about, in this case, if you talk about the line z-axis, we talk about z-axis, can you tell me a point that is confirmed on z-axis? I would always think about 0, 0, 0 originally. Origin is the most common point. And what are the direction ratios of this line? 0, 0, 1. Yes. So if I talk like this, then what is the vector equation? R vector is equal to 0i, the point 0j, 0k plus lambda, again 0i, 0j and 1k. Everything is 0 except the last k. So can I say R is nothing in the first vector but in the second vector lambda with k? So my answer is option C, R is equal to lambda k. It is confusing for some students, but other students who have already learned these concepts will somehow figure it out in the exam. Okay, so what is the vector equation of z-axis? Lambda k. What is the vector equation of x-axis? Lambda I. Vector equation of y-axis? lambda j. Very, very simple concept. Okay, right answer is coming from Smriti, Karthik, G, Shiny, Hridya, Ruben, Hanna. Beautiful, my dears. Beautiful. Very good. Okay, this is another concept again. Didn't I tell you something very important to remember when they talk about in general about the axis? Whatever is not mentioned, that is your answer. So I said that before in the case of y-axis. They gave the opposite, x is equal to 0, y equal to 0, z equal to 0. To avoid confusion, what did I tell you? When they say y, your answer is x and z. Same logic, can you think here? They want you to measure the distance from the point ABC to the points on the coordinate axis. Perpendicular distance, my dears. Perpendicular distance. So, I will tell you the logic very simple in 2D geometry. If this is x-axis and I mark a point x comma y here, definitely the distance from this to a point on x-axis is measured between x, y and x0. So the distance would be what? X minus x squared and y minus 0 squared under the root. So it is actually y squared under the root. Correct? So you are measuring the perpendicular distance from a point to x-axis in 2D geometry. But when the same logic comes in 3D geometry and they are not trying to measure based on any plane but with the axis itself. Okay, so when they measure with distance of this point from x-axis, distance of this point from x-axis, they asked x, then your answer will be y and z. All of you please look at the y coordinate. What's the y coordinate? B. Z coordinate C. So your answer is square root of, so distance from x-axis will be nothing to do with x coordinate but y and z. B squared plus C squared. B squared plus C squared. Okay, so distance from y-axis will be A squared plus C squared and distance from z-axis will be A squared plus B squared. So just keep this logic in mind. So when the same concept comes in 3D geometry, what will be the idea? You're trying to measure the distance of ABC from x-axis. So the point on x-axis will be a comma 0 comma 0. So it is going to be a minus a squared, b minus 0 squared, c minus 0 squared. So b squared plus c squared. That's what I said. You don't need to do this kind of thought process in the exam. Your options will give you the best answer. If you talk about x, answer is y and z. So y and z for x and x and z for y and x and y for z. Option B is your answer. Very good answers already coming from. Yes, let me see. Yes, Hridya, the first right answer. Karthik, G, Sai. Check your answer, my dear. Flip-flops, Hanna, Diya, Hridya. Yes, Sai right now. Okay, so all of you very, very clearly learn this. Just one step. Last year they asked a question from this concept and they asked with one particular axis. So I gave a question for all the three axes. Okay, so they said what's the distance from x-axis? So this just answer b squared plus c squared, and they gave the not ABC, they gave it as 0.235 something like that. Okay, so it's easy. Do calculate and give it back to them. So how do you measure the distance from an axis? Whatever axis they are asking, neglect that numerical value, only square and add the other two. Simple. Now look at this another concept. The coordinates of the foot of the perpendicular that we already showed you. Right? If ABC is the point, my dears, what is the foot of the perpendicular? A0, 0. So what is the foot of the perpendicular from a point to x-axis? Only x coordinate. Y and z will be 0. So what is so special? Y becomes 0, z becomes 0. So here Once again, what is the foot of the perpendicular from the point -3, 4, 5? It's not on the axis, but they are saying it is on the YZ plane. Come on, keep the logic. They said YZ, then your answer is, they said YZ, your answer is X, correct? So what is your answer? They say Y, Z, your answer is X going to become 0 and Y and Z is 4 and 5. Correct? On the Y, Z plane, my dears. So only what is going to change? What is going to become special here? X is going to become special. X will become 0. Y and Z will remain the same. 4 and 5. Okay? Same idea here. When you measure from this point to this axis, A remains the same because it is x-axis, B and C become 0. Same logic if you use here. -3 is becoming 0 because it is YZ plane. So Y and Z both will remain the same. So 0, 4, 5, 0, 4, 5. And the next one is ZX plane. So when you talk about ZX plane, what is not coming? Y is not coming. So Y won't come. So what will be my answer for? I did not get an answer A. Yes, Karthik, Diya, Hridya and Hanna. 3 right answers. Others wrong. Others wrong. Check it, my dears, why you went wrong. Just check why you went wrong and make sure this logic goes inside your head correctly. Okay? Moving on, my dears. Next question. In the figure is not there. Actually, I removed the figure, it's too big. So if the coordinates of P are, because like I said, these concepts, this idea is enough to explain this also. ABC, then the reflection or the image. What would be the image? So if I talk about A, B, C, a point, what would be the reflection of this point made by X and Y? Come on, it is X and Y. Then what is not being mentioned here? Z, right? So who will change, my dears? In that case, who will change? The reflection will be no change in X, no change in Y. But what will happen to Z? Changes, right? Yes. So AB minus C. AB minus C. So if that logic is followed, what is the reflection made by YZ? What is the reflection made by YZ? Yes. So what would you get? What would you get? YZ change X minus ABC. AB minus C minus ABC. A minus BC for ZX. Option A. Very, very simple logic. The reflection. So reflection means what changes. Reflection means what changes. Get the idea? So if I can explain this with 2D for some students who might not get the idea on 3D. Let's talk about x-axis. And the point above x-axis is 2, 3. The reflection of this point in the x-axis is 2, -3 because x coordinate will not change. For this, both the points, x coordinate is 2 only. Then what changes? The corresponding y coordinate is changing. That is, if x is reflecting some point, y coordinate sign will change. Similarly, if xy plane is reflecting, the sign of the z coordinate will change. Simple logic, you keep in mind. That's a trick I told you. Whatever is stated in the question is not important. The other guy, some change has happened. That is important. So look at the option where change has not happened to the person mentioned in the question and change has happened to the other guy. Simple answer. Got it, my dears? Logic very clear? Yes? Okay. Moving on. Direction cosines of this line. Why I put this question is, many students make mistake. Whenever they see direction cosines, they know that direction cosines are what? Direction cosines are obtained by direction ratios divided by the magnitude. We know that. Okay? But many directly take these numbers and get the answer. Wrong. Can you tell me the reason? Because this is one very important thing you must remember and keep in mind even when you're attempting your 5-mark question in 3D geometry. Cross check whether the equation of the line given to me in the question is in the standard form that we have studied. The standard Cartesian form is what? X minus x1 by a, y minus y1 by b, z minus z1 by c. If it's not in the standard form, first make it. So first x minus 1 by 2, 1 minus y is not the correct form, y minus 1 by minus 3. For those students who are struggling in this kind of changing part, I will tell you a small thing you can remember. Look at the coefficient of y. If it is not 1, check what it is. It is minus 1. Look at the coefficient of the y term here, it is minus 1. So you divide minus 1 in the numerator and denominator, it will become correct. So 1 will become minus 1, minus y will become y, and 3 will become minus 3. So here I will divide with 2, z minus half by 6. Now I got my drs. What are my drs? 2 minus 3, 6. Then what are my dc's? I have to divide with the magnitude. So what is the magnitude of this vector? Okay, let me call that vector as b vector. Normally we call it as b vector, all of you, for the line, yes or no? So we'll use the same vector only, b vector. Okay, what's the magnitude of b vector? So 2 squared, negative 3 squared, and 6 squared. Answer 2, 4, and 36, 30. So it's 49. So answer is 7. Magnitude is 7. So your answer for direction cosines 2 by 7, negative 3 by 7, 6 by 7. And I got that answer option, or not C, 1 minute. Yeah, option D, 2 by 7, negative 3 by 7 and 6 by 7. Right answer is coming from Ruben. Yes, Sai, Hridya, G, Sanjay, Smriti, Hanna and Satvik. Very good, my dears. Keep it up. So keep in mind, my dears, a very, very simple question, but where will you make a mistake? You will not see in the exam hall. You know all these things, I know that. But when the exam hall, you might be very careless. That hastiness to finish off a question that you know will force you to make a careless mistake. So make it a habit that whenever you read the question, I will check the Cartesian form and the vector form whether it is in standard equation or not. That should be one point you must check every time. Question: direction cosines of a line perpendicular to both x-axis and z-axis. Come on, something, see, when you talk about the 3D system, x-axis, y-axis, z-axis, we know that all the three axes are mutually perpendicular. So if I talk about a line which is perpendicular to both x-axis and z-axis, the most famous line we can remember is what? The y-axis. Y-axis is the line which is perpendicular to both x and z, the most common one. So any line that is parallel to y-axis is also perpendicular to both x and z. If you have this logic in mind, the question is very simple. So once again, every line perpendicular to both x and y, perpendicular to both x and z axis, implies it is parallel to y-axis. And what did we learn about parallel lines? Same DRs. That implies direction ratio equals, we already learned what are the direction ratios of a line parallel to y-axis. Y-axis 0, 1, 0. So parallel to y-axis also 0, 1, 0. So what are the direction cosines? That is also same. That also we said there. Any line which is y-axis has drs and dc's the same. So direction ratios of any line parallel to y-axis and direction cosines of any line parallel to y-axis are both 0, 1, 0. Option D. Simple logic, my dears. You will sit and calculate so many things to get the drs and dc's. No, keep the logic very simple. Perpendicular to both x and z, parallel to y. Perpendicular to x and y, parallel to z. Perpendicular to x and y and z, parallel to x. Very, very simple concept. DRs and DCs memorize. Okay. Yes, option coming D. Okay, Abu, yes, Hanna, Sanjay, Karthik, Ruben, Shiny. So many gave right answers. Very good, my dear. Beautiful. Okay, the direction ratios of a line parallel to z-axis. Come on, we already said that. Line z-axis. What are the DRs of z? What are the DRs of z-axis? Simple answer. Yes, option D. Finished. This is also board question. I am not taking this from somewhere. I took this from the board papers only. So direction ratios of a line, direction cosines of a line and the axis are all very important for us. And the most famous relationship, L squared plus M squared plus N squared equal to 1, and L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. Yes, so many questions we did based on that logic itself. Okay, now the direction ratios of the line, this time they're giving the two lines. How do you find the direction ratios of a line perpendicular to the lines, two lines? Logic very simple. Yes, it's a very, very common 5-mark type we study in class. But this time I only ask you to find the direction ratios. That is, just take B1 cross B2. How do you find the direction ratios of a line perpendicular to two given lines? Just take the cross product of their direction ratios. How to do that? Determinant IJK. Direction ratio, the first line in standard form 2 minus 3 1. Standard form again 1 2 minus 2. Get me the DRs quick. So 6 minus 2 4i, minus 4 minus 1 minus 5, so plus 5j, and 4 plus 3 7k. So this is my DRs. So 4 5 7 is the direction ratios of a line perpendicular to both the lines. 4 5 7, option A. Yes, I got the Ruben, Sai, G, Abu, Karthik, Dia, yes, Beast Boy, Hridya, Hanna. Very good, very good, very good, my dear. So many of you are responding. Very well, very well, good. Equation of a line passing through 1 1 1 parallel to z axis, passing through 1 1 1, x minus 1, y minus 1, z minus 1, and parallel to z axis, direction ratio 0 0 1. So 0 a 0 a 1. Finished. Board question. Last year's board exam question. Simple question. Find the equation of a line passing through 1 1 1 and parallel to z axis. See, so they are asking you to study the direction ratios and direction cosines of the three axes very, very well. You must be thorough. Very simple. 1 0 0 0 1 0 0 0 1. Simple logic. Okay. The equation of a line passing through the point 2 minus 1 0 and parallel to this line. Okay. So if it is parallel to this line, I should know the direction ratios of this line. The direction ratios, x by 1, correct. Y minus 1 by 2, correct. Oh, this is not the standard form. You have to make it standard, so it becomes minus 2, my dear sir. Okay, so what are the direction ratios of this line? 1, 2 and minus 2, not 1, 2, 2. That's what I'm saying. Careful. You might think, okay, this is repetition again. Sir is teaching the same question again. No, I am repeatedly trying to teach you one very important thing. When the equation of a line is given to you, cross check. Cross check. I have seen this mistake happen so many times. But if the same mistake happens in a 5-mark question where you took the DRs wrong, you are risking 5 very important marks. That's why I'm trying to feed this repeatedly in your head. Now tell me, what is the equation of the line passing through this? It's going to be what? X minus 2 by 1. Y plus 1 by 2. Z minus 0 by minus 2. X minus 2, yes. Y plus 1, yes. Z by minus 2. Option D, beautiful. Okay. Yes. See, somebody has made a mistake and keeping the hands on the head. That's what I'm saying. These mistakes are bound to happen, right? Yes, Shiny, Diya, Sanjay, Hridya, Hanna, Karthik, Ruben, Sai, Abu, Smriti. Very good, beautiful, my dears. Huge responses today for the options because the topic is very simple. I know that, but mistakes, careless mistakes happen in simple questions. Difficult ones, you use the normal process, get the answer. But easy ones, you make mistakes, my dears. Okay, direction cosines of this line. Come on, quick. I want the direction cosines of this line. 6x minus 2, 3y plus 1, 2z minus 2. 6x minus 2, 3y plus 1, 2z minus 2. So make it in standard form. X minus 1 by 3 by 1 by 6. Y plus 1 by 3 by 1 by 3. Z minus 1 by 1 by 2. I want the direction cosines of this. So it's going to be magnitude first. What's the magnitude of this? 1 by 6 squared, 1 by 3 squared, 1 by 2 squared under the root. So 1 by 36 plus 1 by 9 plus 1 by 4. Get the ratio. LCM 36. So 1 plus 9 fours and 4 nines by 36. So it is root 14. So it's root 14 by 6 is your magnitude. So I have to divide each direction ratio with the corresponding magnitude. So 1 by 6 divided by root 14 by 6. So answer 1 by root 14. The first direction cosine is 1 by root 14. Second one, 1 by 3 divided by root 14 by 6. It is 2 by root 14. So 1 by root 14, 2 by root 14. And then last one, 1 by 2 divided by root 14 by 6. It is 3 by root 14. So 1 by root 14, 2 by root 14, 3 by root 14. They are making you to do the calculation with fractions. So please concentrate and do it. Okay, moving on. Yes, if the lines are perpendicular, find the value of lambda. We already discussed a question like this. If it is perpendicular, A1, A2, B1, B2, C1, C2, right? So quickly get me the DRs of this. X minus 1 by 3 by 1 by 6. Y plus 1 by 3 by 1 by 3 equals Z minus 1 by 1 by 2. And second line, X minus 2 by lambda, Y minus 5 by 2 by 3 by 2. And this is given as a comma. Careful, it's Z plus 2 by 0. When direction ratio is 0, they separate that component with the comma. So you rewrite it like this. Now A1, A2 plus B1, B2 plus C1, C2 equal to 0. Multiply lambda by 6. Then 1 by 2 equal to 0. Okay. So lambda by 6 is equal to minus 1 by 2 implies lambda is equal to minus 3. Lambda is equal to minus 3. Option C. Simple property. That's why I didn't wait for calculations. Answer is minus 3. Option C. Yes, already answers came in the chat box. Lambda equals minus 3. Condition very clear? Yes. Now it is about dividing the join of 2 points 1, 2, 3. A very good question for 1 mark. Okay, and this is divided by the point x comma y comma 0 because that point lies on the xy plane. That point lies on the xy plane. Come on. The logic is very simple. You don't confuse yourself. They have given you 2 points and they get the ratio here as k and 1. Assume the ratio is k is to 1. Assume the ratio because I'm supposed to find the ratio. It is what formula? Section formula. So how do you do section formula? x1 into the corresponding ratio. So 1 into 1 and 3 into k divided by k plus 1. That is equal to some value, correct? That is what happens to x. So here I cannot use this relation because I don't know k, I don't know x. But I will go behind, my dears, 0. The z component. So 3 multiplied with 1. So 3 into 1. And 1 multiplied with k. And 1 into k. divided by k plus 1 equal to 0. I will get 3 plus k equal to 0. K is equal to negative 3. If the answer is negative, remember, answer is negative. It is external division. If answer is positive, it is internal division. So what is k is to 1? You will say 3 is to 1 externally. Keep in mind, I just compared the z components because that is the only component given to me. I don't know the other two components. So the only component given to me is z. So I use that z to get k, and that is my answer. 3 is to 1 externally, option D. 3 is to 1 externally, option D. Okay, very good. Ruben, check the answer. Abu, Sanjay, right answers. Only 2 students gave right answers. Very important. Ratio question. They will give you one coordinate. Use that to get the ratio. Okay. Again, here, the point A comma B comma 0, this particular point lies on this line. Come on, a simple question. If this point lies on that line, I can substitute this point in that line. A plus 1 by 2, B plus 2 by 3, 0 plus 3 by 4. And according to the logic of Cartesian form, all this is equal to an arbitrary constant called lambda. So from the last part, I got lambda, my dears. Lambda is equal to 3 by 4. And use that to get the other two. So A plus 1 by 2 equal to 3 by 4. Correct? Compare this. Okay. So A plus 1 is equal to 3 by 2. So A is equal to 1 by 2. A is equal to 1 by 2, there is only one option. I will say option C and finish it off, but just for you, I'll just do that calculation again. B plus 2 by 3 is equal to 3 by 4. So B plus 2 is equal to 9 by 4. So B is equal to 1 by 4. I will not do this normally, but for you, I did it. Because I got A is equal to 1 by 2. There is only one option which says A is equal to 1 by 2. Okay, so I'll take that option and go. But anyway, I said this. They said this point lies on this line, substituted, and they definitely gave one coordinate, like in the previous question. One coordinate is given to find that arbitrary constant lambda here. All of you clear? Yes. Moving on. The x coordinate of a point P of the line is 4. Same logic. The line between what? Q 2 to 1 and R 5 1 minus 2. So get me the equation, please. Equation QR is what? X minus 2 by 5 minus 2. Yes, between 2 points, right? Okay. Y minus 2 by 1 minus 2. Z minus 1 by minus 3 equal to lambda. And they said that the x coordinate is 4. Substitute. X is equal to 4 in this. So I'll get 4 minus 2 by 3 equal to lambda. So lambda is again 2 by 3. I got. Lambda is equal to 2 by 3. From substituting the x coordinate, then what? Simple logic. I want the z coordinate. Go behind this. So z minus 1 by minus 3 equal to lambda 2 by 3. So z minus 1 is equal to minus 1. So z is equal to 0? No, just let me just check. Z minus 1 by minus 2 minus 1 minus 3 equal to 2 by 3. So it's going to be minus 2. Oh, minus 2, I'm sorry. This is minus 2, my mistake. This is minus 2. So minus 2 plus 1 is minus 1. Z is equal to minus 1, option C. My mistake, Z is equal to minus 1, my dears. Yes, good. Z is equal to minus 1, option C. Okay, next, this one, my dears, it's very, very important. It is like you feel many of them to do this with a very long method. Please, they are talking about two straight lines which are intersecting. Okay, at some point, we don't know. This is actually a 5 mark for many of you, but it's not like that. This is very simple. If you want to find something unknown in two intersecting lines, it's a very simple technique. Use the determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, A2, B2, C2 equal to 0. You know what is this? This is the numerator of your shortest distance formula. See, when two lines are intersecting, shortest distance is 0. And shortest distance becomes 0 only if the numerator of the formula becomes 0. This is a very easy numerator. The numerator of a shortest distance formula. x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 equal to 0. So what is x2 minus x1? Difference between the 2 points. 2 minus 1, 1. 3 minus 2, 1. 1 minus 3, minus 2. Direction ratios k, 2, 3, 3, k, 2. Determinant. You solve this determinant, you will get a quadratic equation. Okay, I'm not wasting my time to solve this now. You can simply cross multiply and solve it. You will get a quadratic equation, and from that quadratic equation you must solve for k, and you will get the value of k as two different values, but only one of them is in the options, which is minus 5. C is equal to minus 5. Okay, very clear and very important. Okay, now linear programming is a very simple topic. I can do it very fast. So that's why I just need 10 minutes to finish this topic. It's very simple. Linear programming. Okay. Moving on to that, my dears. Okay. Most of the questions in linear programming could be theory based. You must be knowing the theory of LPP very well. Okay. First one. What is an objective function? An objective function is not a constraint. Definitely not. Is it a function? Yes, because it looks like z is equal to some ax plus by, something like that. Yes, so it's a function. Definitely it is trying to compare values here. And is it a function to be optimized? Yes. An objective function of an LPP is a function which has to be optimized by finding the maximum value or the minimum value. The optimal value is chosen to get the maximum and the minimum value. Is it a relation between two variables? Yes, it is a relation, but it is definitely a function. None of these. Okay, so always learn objective function is what? A function which has to be optimized. Good? Clear? Next, the constraints of an LPP. What are the constraints? Is constraints just linear functions in two or more variables, linear inequalities in two variables, linear inequalities in one or more variables? None of these. My dears, I will say option C. Sir, why not option B? Option B also looks correct, but it's not always correct, because you people are learning only graphical method. Graphical method can only accommodate two unknown variables x and y. That is why you have linear inequalities in two variables and maximum 2 and minimum 1 variable. But there are other methods in LPP which you are not studying, called simplex algorithm and transportation problems and all, where I can accommodate more than 2 variables at a time. I can accommodate 3 variables. I can accommodate 4 variables. Okay, so in those cases your option B is wrong. So constraints are linear inequalities in one or more variables. Okay, clear? Option C. Next, how do you find the solution set for this? Read the options, that is the best. The whole xy plane except the points. So when you talk about the solution set for a line with negative slope, the slope is negative, minus a by b, you know the slope of this line, minus a by b, which is minus 3 by 5, and the slope is negative, so it has to go this way. Okay, there is definitely 2 regions which this line divides, so this whole plane will not come. Whole plane, wrong. Whole plane, again wrong. Open half plane which contains the origin. Okay, let's see if it contains the origin. Just substitute origin in the equation by putting 0, 0. I get 0 less than 7, which is true, so it contains the origin. So open half plane which contains the origin, correct, except the points. All of you, do you see that this is strictly less? Because it is strictly less, I can say something very important about this line. This line does not contain the points on this line. this region will not consider the points. If it is strictly less, it will not consider points on the line. So it is option C. Option C, my dears. Open half plane containing the origin and points on the line is not there. Clear? Understood, all of you? Option D is wrong because it is saying it is not containing the origin. It contains the origin because when I put origin, the region says it is true. Okay? Clear? Very, very important question. Last year also this question came in the boards. It comes every time an LPP MCQ is asked, this pattern. Next one, the optimal value of the objective function. If you want to obtain the optimal value, what should you do? You should be obtained at the points what? Given by the intersection of the inequalities with the axis only. Wrong. Is it always like that? You have solved LPP for 3 marks, right? Do you always get the optimal solution on the axis? Or it's somewhere in the plane also in between? I can get in the plane also. Given by intersection of the inequalities with x-axis only. Again wrong. Correct? Given by the corner points of the feasible region. What is feasible region? That's the right answer. When you are drawing some inequalities, okay? When you are drawing some inequalities, you might obtain a region inside the inequalities with some corner points, and that region is called as your feasible region. What region, my dears? It's called as your feasible region. And why we have a feasible region? Because the corner points of the feasible region is where we are expecting to get the optimal solution. So in this case, what can you conclude? Where do you get the optimal value? Given by the corner points of the feasible region. Okay, only one exception is there for this option, that is unbounded solutions. Sometimes you might not get a solution in the corner points for unbounded solutions, but that is a very, very rare case. So we always go behind option C, the best answer given by the corner points of the feasible region. Okay. Next, moving on, if the constraints in the linear programming problem are changed, what happens if you change the constraints in a linear programming problem? You have to re-evaluate the entire problem because condition changes, diagram changes, plotted feasible region changes, corner points changes. So you have to re-evaluate the entire problem. Okay, not solution is not defined, that and all is avoided. The problem is to be re-evaluated. Next, which of the following statements is correct? Every LPP has optimal solution. Wrong. We do have LPPs where there are no optimal solutions, where no feasible regions are obtained. We cannot get a specific corner point. Okay, so there are no optimal solution obtained. LPP always gives unique solution. That's also wrong because we do have questions where optimal solution is obtained at 2 corner points. Same value, 2 different corner points. If an LPP has 2 solutions, it has an infinite number of optimal solutions. This is one very important thing you should remember. Okay, if I had a feasible region like this, okay, and I got my optimal solution at 2 points A and B, then don't say it is A and B alone. It's a very important question for 3 mark also. If you got an optimal solution at A and B 2 points, you must conclude that optimal solution lies on all the infinite points on this line. That must be a statement for the 3 mark question also. Remember, you must write that. When there are multiple solutions, write the solution exists on all the points on the line containing the 2 points. Okay, clear? Okay, next. Which of the following satisfies both the inequalities? Just substitute and check. -2 you put here, you get -4 plus 4, which is equal to 0, which is less than 10. So that is correct. Okay, you put here -2 plus 8, which is 6 greater than or equal to 8. That is wrong. So first option is wrong because it satisfies equation number 1, but it doesn't satisfy equation number 2. Okay, now 3, 2, if I put, what happens? 6 plus 2 less than 10, correct. If I put 3, 2 here, 3 plus 4 greater than 8, that is wrong. So this is also wrong. -5, 6, -10 plus 6, minus 10 plus 6 is less than 10. Okay, minus 5 plus 12. Minus 5 plus 12 is equal to 7, not greater than 8. Okay, wrong answer. 4 2, this is going to be 8 plus 2. 8 plus 2, 10, less than or equal to 10, correct. Now this is 4 plus 4, 8, greater than or equal to 8, that is also correct. So option D, 4 comma 2. Which point satisfies both the constraints? Okay, next question. The number of corner points, okay, you have to draw the diagram. I am not going to waste my time with this question now. I have more important question later. Okay, with this, okay, this is more important for me. Other one is just like drawing the diagram and finding out where all the solutions is coming. I don't think it's an MCQ type question, but just practice it, okay. Now, the objective function has maximum value 42, which is, you substitute x and y here, 4a plus 6b equal to 42. Then minimum value 19 at the 3 comma 2. So 3a plus 2b equal to 19. So I have to solve this. So I am multiplying this with 3. So I will get 4a and minus 12a. 4a minus 12a minus 8a. 6b minus 6b, 0. Okay, 40 to 19. So 9 3s are 27 and 57. 42 minus 57, it's I got I'm sorry, this is 3 3s are 9, right? So this is not minus 8, okay, so it's minus 5a minus, so 3 3s are 9, so 4 minus 9 is minus 5a is equal to minus 15. So a is equal to 3. A is equal to 3. Only one option has a is equal to 3. That's my answer. If there are two options, put a in another equation, get b. Okay, put a in another equation, get b. Simple answer. Okay, this one again same type. You have to see, find the maximum value, find the minimum value and subtract them. You just substitute this in z. So 30 into 0 plus 24 into 4. 30 into 0 plus 24 into 4. 24 4s are 16, so 96. Okay, and when I put 80, 30 into 8 plus 24 into 0, so that is 240. My dears, these two are the biggest value, not the other one. I've done it already. You subtract these two, you will get 144. That is the difference between the maximum value and the minimum value. Okay, one last question, my dears, one last question. Just stay with me. One last question. Okay, now this is very, very important, my dears. Again, do you see that you have to find the condition between P and Q? Find the condition between P and Q if the maximum occurs at 2 points. Maximum is occurring at 2 points. Because it is occurring at 2 points, both the maximum values are 0. Not same, equal. So z at 15 comma 15 is same as z at 0 comma 20. Put 15 comma 15, you will get 15p plus 15q is equal to 0p plus 20q. So I get 15p is equal to 5q. So q is equal to 3p. Look at the options which matches. The option D matches. Q is equal to 3p. Very important. We did one question before this where they gave you maximum at this point, minimum at this point. Now this is the question where maximum is same at 2 points. So just equate both the points and get the relation between P and Q. Got it, all of you? That's enough, my dears. I have covered all the important questions possible in LPP and 3D geometry. Please watch this video again and again. It's important. It's enough for your MCQ preparation for grade 12 board exam. See you soon, my dears, again. Thank you for your beautiful answers today. Very, very interactive session, my dears. I'll come back again next day with the next topic, my dears. Till then, signing off, Brovin sir. Good night, all of you.